Hey, what's up guys? It's Stephen here from Heresy Academy. Just going to quickly jump in with the most important thing that we absolutely forgot. We forgot to save our scene. Obviously it's not a major issue because we haven't really done any work yet. We've just sort of been talking about and showing a bit of information of what we are going to do. But the most essential thing should have probably been the first thing on the list for setting up the project would be to save our scene. Always I just go Control and S and then it takes me to my assets folder, so I'll make a new folder and underscore scenes. I put an underscore so it registers it at the top. You don't have to put underscore scenes, you don't even have to make a folder. And the file name, well, what should we call it? Angry Birds? No, we'll call it like a game scene or something, because we'll utilise other scenes afterwards anyway. So yeah, that's just the main thing there for setting up the project, just to finish off that last video. I'll probably put an annotation in it anyway, but yeah. So this is the video about our physics engine. We'll keep our sky sprite for now. In fact, should have probably kept some grass sprites in there, to be fair, because you can just use these as our ground. But just for this, let's just double the size again. Just drop this to 25, just so I've got like a big ground unit that I can use for my example. I'll probably duplicate it anyway. Bring it along, grab a pair of them, drop them down, because what we're going to do is, well, we're going to mess around with our physics. So that's that really. To do this, I'm just going to grab random pieces of the physics pack from Kenny. So let's have a look at some debris. In fact, though, let's go for easier shapes. So circle, square, broken square. I don't really want a broken square. I want a nice square. That'll kind of do. Well, it's glass in it, so it's maybe hard to see. We'll just drag these into our scene. Let's have a look at this. Oh dear. Right. One error there is I've grabbed multiple sprites at once and tried to drag them in. When you do that, it tries to set up an animation for you. So be aware of that and just drag one at a time in. So I'll drag that one in. Can't be seen. Let's just go to our sky sprite and we'll just drop this to like -5 or something. No, we're not having this. Oh, it's really tiny, is it? Yeah, it's really tiny. Okay, so let's have a look at what we're going to use. What was that one? I can't even see the thing. Alright, it's a circle, that one is. Let's see if we can find a square. Square. Is that square? It's a broken square. Could do, yeah, that will do. What else? A rectangle will do. Yeah, that one. Okay, so it doesn't particularly matter what it is exactly we use. So 035, 027, and what's going on here now? Oh, is it 001? Just going to grab these over and let's drop these to 50 for now. Let's see if that does what we want. Maybe drop them to 25. I just want them to be bigger so you can see them. Maybe because they're the same colour as the background. Okay, I'll turn the background off. Yeah, that works. So to turn off something so you don't see it, in the inspector, just click on this tick box here, and that does the trick. So, okay. We've got this one. Again, I'll probably still make it a bit bigger actually though, considering how much I've zoomed out on the camera anyway. So for these two square rectangular shapes, we're going to forget the fact that it's actually like hollow. We're not going to mess around with that. Although we'll come into that as we mess around with a bit of mass, but that's a proper setting up, which will actually be in the next video. Sorry, I keep looking at my list to try and make sure I'm talking about the right stuff. But yeah, it's this introduction to physics. So just for a bit of tidiness, just make an empty game object and put the grass fin, sky sprite, put all 4 of these inside there. It doesn't matter, we're not going to keep it like that, it's just so they're out of the way. Although for the 2 grass fin sprites, let's think what should we do. We'll put a box glider on them both, just for now. Like I said, when we properly set it up, it won't be this way. That'll do, it doesn't have to be perfect, you know, just so it lands on it. That's fine. So what I've done there, I should have probably spoken as I did it. I added a box glider, and then the size of the Y, watch this screen or this screen, preferably the scene screen, yeah. So I've changed the size of the Y, because it was like this big before or something. I just dragged it down so it roughly fits where I want it to be. But as you'll have noticed, it folds in on itself from top and bottom, so it would have been offset like this. So in the offset area for the Y, I want it to go down, so we've just decreased the Y to pull down roughly about there, like I said, to make it roughly so it's just above the top, just so the assets land on it for now. We'll mess it up, we'll do it properly for the actual setup along the grass line. We can use an edge glider that you might have seen, or still stick to a box glider, stuff like that. It's absolutely fine for now. And that'll be all we need to set up now. Got these as box gliders. Don't put them as trigger. Make sure that is trigger is off. Editing the glider is absolutely fine as that. So we can close off our other object now. And go to, click on all 3. In fact, I should probably name these, just so we know for our reference. So that's a circle, small square, and big rectangle, or just rect. What's it called now? So, to the square and the rectangle, double click on them both, hold down Control and click them both to select them both. Go over to Add Component, and you go to Physics 2D, or just write box, and then go down to Box Glider 2D. That's one thing to point out as well. Some it may seem like common sense, but it's worth mentioning just in case you're not totally aware of Unity. We're making a 2D game, so be sure to use the 2D colliders. Because if you use a 3D collider, it's going to try and make a cube or a 3D shape. So if you did like a rectangular one, it'd try and 3D around it. It's better represented with a cube, which I suppose I could show you in this one. So to add that, just 3D object, add a cube, and you see the size is pretty small. So let's go to 5 by 5 by 5. So at the moment now we're looking in the scene view because it's not going to be shown very well on the game screen. And we'll see now it's got just a box collider rather than a box collider 2D. So if you have a look at the big rectangle, it's got its box collider on it. Let's just turn the sprite render off a second. So this is the box collider for just the 2D. But if you go to the cube, you can see, like I said, it's made a 3D shape all around it. How to turn this off now? No, don't turn it off. Mesh renderer. There we go. So turned off now the mesh renderer, which is the equivalent of the sprite renderer in a 2D. And you see, like I said, it's made a 3D shape around the entire object. It's not that much. It's not that big a deal if you were to try and create a 3D shape around this. It just wouldn't go too well. If you turn that off, and let's just, for example, add a box glider. You can't add box glider to a big rect because it conflicts with the existing box glider 2D. Okay. So remove the 2D. This is just for example purposes. So now you see the box glider here. It hasn't got anything really to attach it to. We should be able to see, as I'm sort of trying to close up on this corner, it's created a 3D shape around it because our Z is at 1. So it's got 1 unit's worth of 3D-ness space to go around. I don't know what it's called. It's one unit, by the way, as we talked about, the pixels per unit. So this is scaled at 1, 1, and 1. Basically, it's the pixels per unit. So let's have a look, see if I can find an example. Not pixels per unit. No, I can't find. Can't think of an example. But essentially, this is an accurate representation of one unit here, because all you got on the Z is absolutely nothing. So it's replicated both on the same side. Whereas if you go to a front view, like I say, it's not very good to show an example on a 2D object, but it doesn't give you any extra space like on the side of it, because it knows where to go to on this one, whereas the for the Z, all it's got is this basically one thin strip, which, you know, it can look quite big. Yeah, it can look quite thick if you zoom into it, but like basically this is just one, and it's not really got anything to go 3D around, so it represents itself as one unit across. So obviously, if I was to scale it by 2, it's basically as it sounds, times it by 2, times it by 3, times it by 4, 5, etc. But yeah, so that was just trying to give you an example of the difference between a 2D and a 3D collider. We want to stick to our 2D collider just because it's general setting for our 3D game, our 2D game, sorry, not 3D game. And just quickly now to show you this corner, you have got an accurate one line around it now, sort of thing. And you won't be acting in the 3D world anyway throughout this game. You will be going left to right, which is your x-axis, and then up and down, which is your y-axis. But you won't go from like this position to this position, but so far backwards, anything like that. The only time you'll really be looking at the z-axis would be if you were setting it up to try and just change positioning or change the ordering layer and stuff like that. But that's better done in the sorting layer and the ordering layer, but that's nothing to do with physics, so we'll leave that for now. So now I've got our 2 box gliders. Let's go to our circle, and just straight away I'm just going to basically try and hurry this along a bit. I'm going to put a circle collider 2D. As you'll notice, you didn't have a circle collider no D, or just circle collider, because it's a sphere collider, because that's what a 3D circle is. Well, yeah, that wouldn't work on this. If you're not happy with the size of it, which I'm happy with, that'll do for what we want to do. You can obviously change the radius, which is the overall size, which I believe is at 1.4. You can change its position with the offset still, nonetheless. But we're happy with this. So now across all 3 shapes, I'm going to go to an add component. I'm going to add a rigid body, 2D. Make sure it's 2D, and we're going to give it a gravity scale of 1. And actually, I think that's going to fall through the floor, to be fair, just to save the scene. We're going to make sure his kinematic is off at the moment. And we'll just quickly drop this down, see what happens. It might go through our thing, our floor. I'm not sure if it would, if you need a rigid body on it as well. No, it's fine. So as you can see, the ball is rolling off because of the circle collider. You'll see that it's not landed perfectly on the grass, because obviously we've set up the watch collider just above it. But let's hope you notice that. If you see what happened when you put both of these underneath, like that, you'll see all of them drop on top of each other, and the ball should squirrel away. But possibly now this big square will hold it down. You see, the first time the ball was rolling away. But now we've set it up so it lands on a square and a circle, and it just stays still. So most of this game, most of the setting up for this game, if you want to set up funky structures, so you drop that there. I would obviously recommend getting it set up properly so that when you press play, everything's in position and it's not going to fall. But let's try and just quickly draw this out. Okay, we can drop down 2 units, I suppose. So drop this, drop this, drop that. Hang on. Yeah, you can go one more. That should do. So yeah, so you want to set it up so when you press play, everything is in position, rather than having it fall, because it's got the opportunity to bounce. You can set things up with materials to sort of add in friction so that doesn't happen. It's just trying to line this up. What we want to do now is we want to just give you an example here now. So the bottom one shouldn't move, and these two didn't either, which is good. And I didn't want it to maximise on play, so I'll just turn that off. Because I want you to look in the scene screen. So if you look over here now, you see these are in position, these are fine, and then the ball will drop. But it's got no other acting forces. This is where physics comes in now. It's got no other acting forces, so it's not going to drop and roll. Whereas if you just drag it like that, you can see everything wobbled, and it wants to roll a bit. You can see it sort of slowly rotating, and if you leave it long enough, it'll fall off the side and possibly roll off the edge. So I'm hoping it'll do that a bit quicker because I want to show you that. You can see its position changing slightly on the X, very slightly, change on the Y, and it's rotating on the Z. And as you can see now, it's getting closer and closer to the edge. It's going up now, 20 on the X. The Y position is like fluctuating because obviously not actually going up and down, it's just rotated a bit. Come on, there we go, there we go. Now it drops, and it did a little sort of bounce, but we don't have any bounce settings on. And then I'm just going to grab it before it falls off the edge. So drop it down in there. As you see, it'll start rotating and rolling again. And it pushed that a little bit, but not much. So you can get it to push it off, and just keep, So you can mess around with the physics here, and it's going to slowly rotate again. So what you want to do, you can drop this down square, and we've got the box glider set up pretty accurate. So if you tap this on the edge, you'll see it rock and fall, and you can even mess around trying to scoop things up and push it along. If you go too quick, it'll just like fly through things. But as you saw that there, it's like pushing something underwater. It wants to go through because you're colliding with the box glider of that, and it just bounces back up. So that's setting up a bit of the box gliders, having a little mess around with that. So what we can do next. You've got here where you can set up the mass of it, but we don't need to mess around with the mass too much. You can change the angular drag, keep this, well, let's put this to 1. Sorry, the linear drag. Put the angular drag to 10. Let's see what sort of changes we can make with that. The ball was probably a bad example. Drop this, it hits off the edge there. See, slightly there, it didn't rotate, and now it stopped rolling. So that's because of the extra forces we've just added now. So it falls, and it just doesn't really want to go anymore. Drop the angular drag back to 1. Well, let's use it 0 before. Drop it along. You see it acts out a bit more, but it's still got these drag forces, which are essentially dragging it, pulling it away. So if you're pulling someone away from a fight, you're dragging them, you want them to stop. The stronger your force, the quicker you'll be able to do it. So you can put also the gravity scale to 5, and watch what happens now. You just drop this straight down. But if you grab, let's say you grab these 2 items, I'm just going to drop them from here. It's a bad example because they're in different positions, but you see how long it takes the square to come down than it does the circle. That's obviously we've put more gravity on them. When you go to the circle, just try putting a -1 on the gravity, it lifts itself up. So if you want to do an anti-gravity game, you just hit the box glider on the bottom of this now. So that's now messing around with the gravity, the drag, the mass. Let's put the gravity back to 1 for everything. Oh no, let's not do that just yet because we'll lose my asset. Let's change the mass on this to 100, and the small square, we'll put it to 10. What I'm going to show you now And make sure we select the circle and small square. Drag them both up. They both got the same gravity but different mass. And you see what's happening here is I forgot to put these back in there. Yep. I do. Let's just put the drags back as well. The circle and square. Let's go again. So let's drop them now. Both got different masses, but they've got the same force of gravity. Now, that famous scientist person, which I'm pretty sure I should have remembered the name of, taught us that the mass doesn't matter as long as you've got the same force of gravity, or something like that. There is a more technical way of saying it. But yeah, so if you want to change things up, the mass will come more important later on. So we put these back to mass of 1 now, because you've seen that that's not important. Oh, the angular drag is 0.0 something, 0.05. So just make sure they're all the same again. One thing to note as well, no matter what I do now, I can change all the physics, change everything I want in here. But because I'm using it in play mode to give you sort of a live preview of how everything works, when I click off it, everything will revert back to the way it was before I click play. So it's really good if you just wanted to test something out and check what this is going to do. Click play and test it out. Quite simply, that's all you need to do. You can use auto mass, but I'll just base it off like size. Well, yeah, just size really. So let's go to the big rectangle and auto mass. The mass of this big rectangle is 49.28. The mass of the circle is 6.15, based off the size. So you might not want to do that. Like I said, it would be hard for you to decide just yet if you don't know what the mass is going to be used for in the game. This will come into play a little bit later on. There is kinematic. Let's now put is kinematic on our circle. Let's put a gravity of 10 and let's drag it there. It's not moving at all. And the is kinematic will come in very useful afterwards when we start setting up for like the slingshot and even the structures as well. If you want to do some tricky structures and you want to just use kinematic to test it out without having them all fall over completely. Essentially, it just tells this rigid body component that it's not affected by physics, and then as soon as you turn it off, boosh, it's back to normal. So the way you turn that off, obviously, you can click it on your inspector view here, but if you're in the game, like you wouldn't have the inspector view, you wouldn't have the hierarchy of the project, and of course, me pointing at the screen isn't going to show you that. But I did it anyway. So you'd use a line of code where you reference your rigid body 2D component and then you just put is kinematic equals false, and then that turns it off or turns it back on. So like I said, you can use it to start some things up. You can build a little structure, and then if you wanted part of your game where you just had something naturally fall over time, you could set it up in an update function to do a bit of a timer and then have it fall. If you had something like a plank of wood that looked pretty weak and you just wanted to show it deteriorate over time, you can do an animation, or when the animation stops, have it destroy itself, and have everything that you had positioned behind it is not kinematic, because you have like a funky shaped structure, and just have it all fall over. But so you turn off the kinematic feature once that animation is finished, once it's been destroyed perhaps. Another thing that's good, it will come in useful when we do our slingshot. We'll have it as kinematic, so we can move it around without exerting any force. And what we will use is, we're going to our components. We'll go out with the search, and we're going to go down to our physics and drop down to here. It's called a spring joint 2D, and as you'll see, it's already decided to give itself a position. Let's say we just drop that there and then turn off the is kinematic. See what's happening? It's swinging from this pole, even though there is absolutely nothing inside the game view. We've told it a point to swing from. So you can obviously, oops. No, it's not working. Essentially, it's just going to keep dragging itself and then just pull it back up, and you can see that's That's a better example now. We use the spring joint to have it so we can pull the slingshot back, which will be basically we'll pull our ball and it'll be connected to the slingshot, so as soon as you let go it'll essentially pull back to its position. So let's just turn off the kinematic, put the gravity scale back to 1, that's probably why it's acting out a bit. Let's say you put that there and the starting point was here, so we turn kinematic off. It's obviously hanging now, so what you'd do is you'd pull it back, then let go, and it'll swing to it, it'll snap to it rather than swing the way it is now. It's not doing it. We will need to do a bit of coding though to set up a fixed position. So to say, if you see where the ball is now, let's see if I can zoom in. Oh no, you can't see it. I'll zoom out then. See the two green lines that sort of appearing here. Same around the origin point of like the spring. What this is, we'll basically set up a piece of code where we can set a position in here that'll say that's where it goes, that's the end point. So brake force, no, I don't want to mess with brake force. So no matter how much we pull away, it'll the asset will be stuck in that position. So our mouse could be over here, still dragging, but at the same time, mouse will be here whilst dragging it, and you'll still be able to aim it as well. Because I even do it in Angry Birds where you touch it with your finger and you pull it back, and after a certain point the bird doesn't follow you all this way, but you're still able to aim it from back here. So that's one thing we're going to use is the spring joint. Actually the rigid body is very important, and that'll be explained further when we come to actually using it, because like I said, I'll go through the mass, go through the linear drag, angular drag a bit better. The gravity scale, we'll probably keep this at 1. But what a fun thing we can do, in one of the pictures I showed you, it's got them fans. A fun thing to do would be, whilst we've got the gravity scale here of 1, you can mess around with the gravity a little bit. So just have a visual aid of putting in a fan and some what looks like a wind effect. None of these actually have to do anything, apart from just have a trigger collider. So as the ball falls through it, then you can just like manipulate the gravity a little bit and have it boop up. And then after it falls through a certain point, or it moves a certain position, it resumes back to its normal gravity and comes back down again. So that's how you'd set up the force of a fan. But I'll do that in an actual proper video and properly show you how to code it and set it up and everything. It is kinematic, I've gone through that now, so it just basically turns off the physics, and then you just turn it back on, it'll go back into motion. Interpolate, sleeping mode, collision detecting, we don't need to do that. The constraints, we can freeze the rotation on the Z, but let's say we did that now. I'll turn it to kinematic. What you'll notice, it no longer rotates. It's not really visual on that because it looks the same all around. But if you look in the scene view and you take the freeze off, 1 second now. No, it's not there, it's not there. Just trying to show you now. There you go. So you see how it's rotated now, but then you turn off the freeze rotation. The only rotation you'll see up in the transform object is on the z-axis. So if you freeze the rotation, that basically your object, like your circle, it won't roll, it won't do what it's supposed to be doing like that. It is good in some aspects because you can keep the sprite looking and facing the same way. If you do want it to rotate, then leave it. If you want it, like I said, if you want it facing the same way, you turn off the rotation, stuff like that. We can disable the spring joint now because we don't really need to use it. I'm just sort of showing you an example. That's really it for the introduction to the physics. We've gone through circle, mess around with squares. One thing I've not done really is just sort of drop a square on the circle, just to show you it's fun to see things fall. And I just grab a small square, drop this on, drop that on. Just like I said, I mentioned in the last video, the physics part of it will basically be just messing around, seeing what works, seeing what doesn't. If you have a good understanding of physics, then great, you'll understand more. Like when you're working out for your scripting, you will need to understand a bit of maths, how drag works, a bit of mathematics to how everything works together, understanding a bit of physics. Physics. So yeah, that'll do for this video. Like I said, it's just going to be an introduction to physics, talking about it. In the next video, we will start up setting up our level structures. So we'll go make really basic, perhaps using these grass tiles, and start setting up some structures, saving them as prefabs, maybe save the ground as well. We'll save them as prefabs because later on when we do start setting up our level system, we'll load in and instantiate these prefabs. So you can load level 1 and it'll have an easy system. When it checks it's level 2, you can change it to be a different prefab, stuff like that. Well, that comes a bit later on. So again, now an example of what I said before about the play button. If I click play, everything goes back to how it was, nothing's changed. So yeah, that's it for this video. If you liked it, give it a thumbs up. Be sure to subscribe to catch on to the next videos, and have a nice day.